Hi there. Episode 4 is a big one. So big in fact that I'm breaking it out into 4 smaller videos. If you missed the previous episodes, you can find them on the channel. Over the course of the 4 parts, we'll look at the player scene and its components, including covering basic game dev topics like player stats, movement, the state machine, camera, collision, light, and sounds. In this first part, we'll go over the CharacterBody2D class that we use as a foundation for our player character movement. We'll get our first good look at the script and the scene tree for the player object, and we'll focus on the concept of player properties like movement speed and health points. Let's get right to it. Here's the player scene tree. It contains a bunch of children nodes that handle all sorts of things for the player. The focus of this video is the top-level player class and the child player stats class. We'll look at those 2 scripts in a moment. First, let's look at the custom settings that we can change directly in the editor for the player and player stats nodes. These variables are exported from the class and into the editor using Godot's GDScript export annotation. And we'll see those exports in a few seconds. We've added these custom variables to our player scene. We can make the player start with any of the items in the game if we want to test them out, change the way the camera works for the player, and also change many of the physics engine parameters that we need to make a simple platformer. Each of these can be changed in the editor to see the effects directly in the game in real time. The player stats scene is where we'll store things like hit points, stamina, or a mana pool. To keep the demo simple, we only have a health pool. And here's where you can change the player's max health directly in the editor. If a node has a script attached to it, it will have this icon, and you can click on this icon to open the script in the editor. I won't show a full example here, but you can also use this button to attach a new or an existing script to a node. We already added a script to the player scene. Our player scene is directly based on the CharacterBody2D class from Godot's 2D physics engine. This is one of the easier ways to move player objects around in a Godot game, and it gives us a very useful move and slide function to help move the player around without having to write tons of code. There are other ways to move Godot physics objects around, including rigid bodies and static bodies, but we found the CharacterBody2D to be a good fit for a controllable character in a simple platformer. You can read up more about the CharacterBody2D physics on the Godot engine website. Our player scene gets all of the awesome features that a CharacterBody2D normally gets, but then we also added several other settings to further allow us to customize the way the movement physics will behave in the game. Let's dive into the player scene script and look at some of these custom settings and features. We saw these settings a few moments ago in the inspector, and here they are exported in the player class script. The numbers can be changed and tweaked, but we found that these values created a good place to start and allowed us to easily move the player around with the PlayStation 4 DualShock controller. We also have several switches that tell the game if the player has given an item upgrade or not. When the player picks up the items in the game, these flags will be set to true. Or we could set them in the editor to test the upgrades right at the start of the game. We'll look at the bullets in the next video when we discuss collision shapes and detecting collisions between objects in the game. For now, see how we're creating a bullet scene here using the preload function? We'll make clones of this object later to create new bullets on the fly, based on the direction the player is pointing. To keep the code more organized, the player stats like hit points are stored in a PlayerStats class. We'll look at that class in a second. In our onReady function, we'll hook up the player stats signals to our main player class. That way, when the player stats are changed and the appropriate signals are sent from it, our main player class will receive the signals and execute these custom functions here. Godot signals can be used for most anything, but these specific signal examples are because the player is either taking damage or healing damage, or they're just plain dead with no health left. Signals are vital to using Godot, especially if you need to communicate or send data and events between complex scenes. These damage functions are a good example of how they can be used in your own code. You can read more on Godot signals here. Just a side note, this demo is using the new Godot 4 syntax for connecting signals. We find it much easier to use and more efficient when we need to hook up our own signals. If you're migrating a game project from Godot 3 to version 4, then this is one area where you'll probably need to change due to the syntax. The game loop will process the player scene on each tick of the physics engine, in the physics process method. Each tick, the game will check and handle changes to the camera, handle firing the player's gun if they have one, and check to see if the player just used one of the in-game switches or toggles. That covers the basics of the player script. Now we can look at the simpler PlayerStats script. Most games have multiple types of stats that a player must manage. We can add more later, but for now we'll just keep a pool of hit points that has a maximum value of 5. We've exported the max health property so that we can change it directly in the editor. Here's how we handled a simple set of signals that can be sent when the player's health is changing or is depleted. You'll notice in these functions below we emit these signals when certain events happen. Any game objects that are listening for the signals can run custom code, and in fact that's how the player scene knows when the player actually took damage. The last part of the player stats to mention is the invulnerability frame logic. In many games, when a player takes damage, they become invincible for a very short amount of time. This is commonly referred to as iframes. During this window, the player cannot take additional damage, and may or may not have control over their character. Here's how we created a dynamic timer directly in code to set the iframe window to be about 3/4 of a second. We found this to be a good starting point, and it can be changed very easily. Well, I think that covers enough for this first part of episode 4. In the next part, we'll show how the player scene is drawn to the screen using sprites and animated sprites, and we'll focus on the topics of collision shapes within Godot. I hope you found this helpful so far, and if so, please leave a comment, like, and subscribe to the channel. It means the world to us. Thanks for watching.